This is lesson 12.2, and in this lesson we will be talking about bar graphs and histograms. Okay, there's some vocabulary we need to start out with first. So first of all, frequency counts. That's just how often something occurs. So if you're taking a survey and you're asking people, what's your favorite animal? And you have people say dog and cat and horse and mouse or whatever. And if you have like 3 people say dog, then that's the frequency count for dog. And 15 people say mouse, and so that 15 would be the frequency count for mouse. So frequency count is just how often something occurs. A dot plot, we saw that in the last lesson, and that's where you have the x-axis, and then you have dots showing the frequency count of something. So you can see how many dots are representing a particular choice. There's 2 types of data that we deal with, and they are called categorical and numerical. And so let's talk first about categorical. Categorical is also called qualitative data, and a way to remember that is just it's like categories. And it's data that can represent non-numerical groups, like how many or what's your favorite animal, or how many of each color car is in the parking lot, and so you say red, blue, green. And so that's when you have non-numerical data. When you have this qualitative or categorical data, you're going to use a bar graph to display that data. And so what a bar graph is it's bars that are going to show like the frequency count, like that. Now let's talk about the second type of data, and that's numerical, also known as quantitative. And the way I remember that is like quantity is a number. So numerical or quantitative data, that's where you have numbers being what you're keeping track of. So how old is everyone? So people will say a number. Or what's the blood pressure? And so people will give a number. What are test scores? That's a number. Now the difference with the numerical or quantitative data is that you're not going to use a bar graph to represent that. You're going to use a histogram. And so a histogram is very much the same, except for all of the bars are connected. So there's no space in between them. And so that's a histogram. So when you see a bar graph or a histogram, a lot of people think that they're the same thing and it's just a matter of aesthetics, but it's actually a difference in the type of data that they're representing. So I think I've already talked about the bar graph versus histogram right here, so that's that. The next thing we're going to talk about is data that's skewed. Now first off, this that we're going to talk about right here, that's only good for numerical data. You cannot talk about skewed data when you're talking about categorical. It doesn't make any sense. So let's talk about skewed data. And so when data is skewed to the left, it means that the data is concentrated on the higher values, and so there's not very many on the lower values. And so there's what we call a tail to the left. Skewed to the right is the opposite. The data is concentrated on the lower values, and so it has a tail to the right. We'll look at some pictures in just a second. Symmetric is when it's not really skewed left or right, but it's pretty much even, so it's usually high in the middle, and then it goes down on both sides, so it kind of has tails on both sides. Now keep in mind that none of this classification is perfection, and so even when we say something is symmetric, it's not going to be perfectly symmetrical, especially if you're talking about data. So if we look at some pictures of that, I've got these dot plots, and if we look and see how they're skewed, we can determine like what type, are they left, right, or symmetric. And so let's start by looking at a symmetric one. So if you look at these 6 graphs, which ones look symmetric, like even? And so they're high in the middle, low on both sides. So hopefully you're seeing that this one looks symmetric. Now you can tell by looking at the dots on the dot plot that it's not perfect. It's not perfectly symmetric, but it's pretty close. You've got the concentration of data higher there and then lower on either end. Do you see any other graphs that could be symmetric? So you might have noticed this one is symmetric as well. So those 2 are symmetric. Okay. Now if you look at the other ones, the other 4 are examples of either skewed left or skewed right. And I think it's a little bit counterintuitive, because if we say skewed left, I kind of think like everything should be on the left. But it's actually, the data is on the right side and there's a tail to the left. So if you look at this one, like right here, it kind of drops off at the beginning and then it goes higher as you get towards the end. This one is also going to be skewed left. And so think about it like a dinosaur, like if you're drawing a picture of a dinosaur. I don't draw, but anyway, if you drew a picture of a dinosaur, where would the tail be? And that's how you're going to know which way it's skewed. So then the other ones, if you look at the other ones that are left, we've got this where we've got data at the left side and a tail on the right, and that's going to be skewed right. So again, it's not meant to be perfection, and so you have to look and say like, well, where is it concentrated more? So especially when you're trying to decide if something's symmetric, please don't think that it has to be perfectly symmetric in order to say it's symmetric. Okay, let's look at this next set of problems. So survey percentage of men spending at least 1 hour per week exercising by age. So we went and found out like how much men exercise. So men that were 16 to 24 in adolescence, 62% of them said that they spent an hour or more per week exercising. Young adults, 43%, and then 35%, and so on and so forth. When we got to advanced age, over 75, we've got 4%. Okay, so you notice that as men get older, they are less likely to be exercising. So the big question here is, would we make a bar graph or a histogram? And how do you decide that? So basically we need to decide, is this qualitative data, whoops, I can't spell, qualitative, or categorical, or is it quantitative? Now, one way that is like a really good way to tell is if you were to make your graph and you're going to put like this information on your x-axis. So if I say like adolescent, and then I go to like, dot, all the way to advanced age, would it make sense to mix it around? Would it make sense to put like the 30-year-olds here, and then the 16-year-olds here, and then the 50-year-olds here, and then the 70-year-olds here, and then the 20-year-olds there? Would that make any sense? It doesn't make any sense. And so because of that, this is numerical because it's based on the ages, it's age categories. And so even though you can group them as categories of adolescents, young adults, adults, it's still numerical because it has to be in a certain order to make any sense. So when we go to make our graph, I'm going to actually write 16 to 24-year-olds, and then I'll do 25 to 34-year-olds and so on. I was going to do different colors. So, okay, I've got that put up there on the x-axis. Now on the y-axis, what am I going to put there? And so what am I going to be counting? I'm not counting how many men we counted because I don't know that, but I do know 62%, 34%. So I do know the percentages. So over on the y-axis, that's going to be my percentages. And so as I go to label it, I'm not going to do 1, 2, 3, 4, 5, 6, 7 all the way to 100 because that would be too tedious and I don't need that much information. But what I'll do is I'll maybe go 5, 10, 15, 20, 25, 30, and so on. And so go ahead and make your graph. I don't have to go all the way to 100 because the highest I have is like 60 something percent. So if I go to 65%, that will do it. So this right here is 60%. And so that's as high as I need to go. So that takes care of my x and y axis. Now because we've decided that this is numerical or quantitative, I'm going to make a histogram. And so that means my bars are going to be connected. Okay, so we're going to start out. So 62%. So I'm going to come over here and I'm going to find 60 and I'm going to go a little bit above that and I'm going to make a bar for 62%. And then I'm going to look at the next one, and the next one is 43%, so I'm going to go just above the 40. I'm going to follow it across. Maybe a straight edge would be a really good thing to do. And we're going to make another bar for that one. And so we keep doing that, and we just need to make sure the bars are connected. It's really helpful if you've got everything evenly spaced on your x-axis, which I kind of don't, so some of my bars are going to be fatter than the other ones. So that would probably be something that you would want to do better. Just given what I'm trying to deal with, I'm not going to go back and erase all of it. Okay, I gave up and went back and removed my numbers because it was just looking too weird. So you want to have your bars all connected. Colorful and visually appealing is always more desirable because if you have something that's not visually appealing, nobody cares what you have to say. So if you're giving a presentation or you're making a poster, if you don't make it visually appealing, nobody's going to be interested long enough for them to understand or to care about what you're saying. So you know that if you're doing, a science fair project, you want to have it at least be interesting enough that somebody's going to stop and look at it. And so use colors, use graphics, whatever. So I've had some people that, they do like little designs in each one of them or different colors or whatever. So just do something so it looks nice. The other thing I would do is, because based on the information that we have here, like with my 75 and up, if you look at that, I'm not really sure if I was just looking at the histogram where that falls in. Is it like 3%, 4%, 5%? I don't really know. So a good thing to do for that would be to put like 4% right there and 8% right there. Again, this goes back to making a graph readable, legible, something that somebody looking at it can quickly understand what your information is. If you're not going to do a graph well, then just don't even bother. So make sure that you make it good and present it well so that people have the information that they need. Okay, so that's what we need right there. Now, as far as looking at the information we have, so a couple of things that are very important. What conclusions can you draw from the histogram? So when you look at this information, what's a conclusion that you could make? So I want you to pause the video and I want you to think about, like, what are some things that you know, and don't say something like 4% of men 75 and up exercise an hour a week, because we've already stated that. So go and say something else, like, that hasn't been explicitly stated, and then come back. Okay, so I'm not going to write this down, but for number 3 with the conclusions, you could have said things like, as men get older, they don't exercise as much. Or you could say, young men are more likely to exercise than older men. Or, something along those lines is probably the conclusion that you would make from looking at this data. Okay, let's look at number 4. What does the mode represent in this situation? So if we were to say that there was a mode, how would you say that? Because it's kind of tricky in this situation, because it's kind of like, well, is there really a mode? And so you might think, well, this could be the mode, because you could say adolescents exercise the most often. And so that could be an argument there. If you don't have numerical data, you absolutely cannot find a range or a mean or a median. But even sometimes with numerical data, like in this example, you couldn't find a mean or a median here either, because you can't add up all the percents and then average them, because that's not really what we're talking about. So this is kind of an interesting set of data. So as far as the mode goes, you could say that it's, young men, 16 to 24, but the way that it could be confused in this situation is because you're not really having an answer that's most often, because we're just saying, this many percent do this exercise. Okay, could you take number 5, could you turn that histogram into a dot plot? So what would you do if you were making a dot plot for that? So let's think about that. If I was to make a dot plot, the x-axis would look pretty much the same. So 16 to 24, 25 to 34, and so on. But then instead of the bars, I would need dots. So what are you going to do? Are you going to do like 62 of them right here? And that would mean that there were 62 people. And that's not really what it means. And so as far as a dot plot goes, you can't really turn that into a dot plot, because you're not talking about frequency. You're not doing a frequency count, I guess is what you would say. Not a frequency count. So when you're having percentages, then that's not the same thing as a frequency count. So even with numerical data, categorical, you may not be able to do all the things with that type of data. So if you have a particular set of data points, you have to really think about what the situation is and how does that apply. In order to make a dot plot, what information would I need? Basically, I would need numbers and frequency count. So I'd have to know how many men said that they exercise more than an hour a week. So you could say, so if I, surveyed, 100 men from each age category, I'm having a hard time scrolling this. If I surveyed 100 men from each age category, and I said, okay, so, 62 of them said that, and, 38% of them or whatever. So you could do that if you had a specific number, but you can't do it with a percent alone. Okay, the next set of data is we have got a dot plot here, and it is about the number of raisins that are in a box. So you've got a little box of raisins, and you're going to see how many raisins you've got in the box. So you've got a box with 25 raisins, you've got 2 boxes with 26 raisins, and so on. So that's how you're reading a dot plot. So when you're told to make a list from the data, you're going to start with 25, and then we're going to say 26, and we're going to say that twice, because there's 2 dots for that, and then we'll say 27 3 times. So you need to be able to read a dot plot so that you can make a list of data. So I'm just going to put continuing. So you go ahead and pause the video. You are going to finish the list. you're going to find the mean, you're going to find the median, you're going to find the mode, you're going to find the range. And then tell me, is the data skewed left, right, or symmetric? Then turn the video back on, check your answers, and make sure you got it right, and then we'll finish this up. Okay, the answers you should have gotten. So finishing your list, of course, your mean, you should have gotten 475 would be all the raisins added together divided among 17 boxes, and that's 28 as far as the nearest whole, because it was 27.9, so it's 28 is the mean number of raisins per box. The median in this case is also 28. When you had your list of data, the 28 was in the middle. And then the mode was also 28. Now here's something to remember. If your mean and your median and your mode are all the same, that's a really good bet that we're talking about symmetric data. Because if it was not symmetric, then there would be one thing to make it lean more one way or the other. But if you look at this data, that looks very symmetric. Not perfect. Remember, we're not looking for perfection, but it does look symmetric. So as far as what type of data we're looking at, and this is just a clue, if the mean, median, and mode are either the same or very, very close to being the same, you are probably looking at symmetric data. And then the range, of course, is going to be 31 minus 25. Now, that's not your answer. You're going to actually subtract 31 minus 25, and you're going to get 6. So 6 is your range. That means that all the boxes are within 6 raisins. Okay, and then the last part of this is just explaining what the different things mean. So what does the mode represent in this situation? So when we say something about 28, we're talking about the mode. So we know that, 28 is the most. So would we say something like most of the boxes have 28 raisins? Is that true? If you look back at here, do most of the boxes have 28 raisins? Actually, most of them do not have 28 raisins. You've only got 5 boxes with 28 raisins, and 5 out of 17 is not most. So what you would say is you would say that more boxes have 28 raisins than any other number. So more boxes or you could say 28 is the most common number of raisins to find in a box, or something like that. Do not say most of the boxes have 28 raisins. What conclusion or conclusions can be drawn from the dot plot? So answers can vary here. So if you look at this, you're not going to say something like there was only one box with 30 raisins, because that's already been stated in the dot plot. So don't say something like that. But you can say something like most boxes have between, this many raisins, or come up with some other explanation for something that you could draw a conclusion about in your dot plot. So one thing you will have to be able to do is draw conclusions from various types of graphs. So whether it's a dot plot or a histogram or a box and whisker plot when we get there, or any other types of graphs or two-way tables, you're going to have to be able to draw a conclusion and know what you can conclude and what you cannot conclude. So make sure that when you see these kinds of questions, you really concentrate on getting those right. Okay, the last part, write each answer as a fraction and then as a percent. So what percent of the boxes sampled have 25 raisins? So if we look back at our dot plot, we only had one box with 25 raisins, so it was 1 out of 17. And so you're going to turn that into a percent. And so that percent is 5.9%, rounded to the nearest tenth of a percent. What percent of the boxes that had less than 30 raisins have 27 raisins? So how many boxes had less than 30 raisins? So if we look back, less than 30 is that many. So that's going to be 15. So out of those 15 boxes, how many of them have 27 raisins? So it's 3 out of the 15 boxes that had 30 raisins have 27. And so that comes out to be 20%. And then what percent of the boxes had 28 or 29 raisins? So if you look back up at your dot plot, the 28 or 29, that's going to be 9 of the boxes out of the 17 boxes, which is 52.9%. Okay, you should now be ready to complete your assignment for 12.2.